All right, Mr. Dean here. Time for another video, this time about inverse trig. It's part one of two. Here goes. First of all, inverse trig functions are inverses, not reciprocals. We'll come back to that idea a couple of times. Remember, trig functions take an angle and they return a ratio, or like a percentage, if you think of it that way. So, for example, sine of 30 is a half, or 0.5. It means a 30-degree angle. Generates a line across it, or a side across it, that's half as tall as the maximum height, which would be all the way up at 90 degrees. Inverse trig functions allow us to work backwards and are written as either sine to the -1 or arcsine. And one of the reasons why it has two ways of being written is because people are trying to get away from the idea, or the confusing idea, of thinking of that um, as an exponent. Because we've already seen sine squared theta. So sine inverse sine like that does not mean, let me be clear about this, does not mean 1 over sine theta. Let me get that out of the way. All right, so that is definitely not the same. So they're inverses, not reciprocal. So for example, put it in action, inverse sine of 0.5 is equal to 30 degrees. Of course, if you're in radians, it would, you'd calculate it, say, you'd get back pi over 6. So you're on a boat, and you got enough fuel to sail no more than 2 miles. You're currently a quarter mile from shore. The waves are pounding behind you, so you can't motor straight to shore. What's the largest angle you could use and still reach land? Your shipmates never pass pre-calc, so they look all to you. What's your educated guess? So right now, what's your educated guess, without too much calculating and worrying about inverse trig? This is not to scale, so that's a quarter mile, and you are going to go out no more than 2 miles in that direction. All right? Take a guess. Take one of these four answer choices, 20, 40, 60, or 80 degrees. What do you think? We're going to reveal the answer in just a moment. If you said D, 80 degrees, you are right. So you already have a pretty good feeling inside about inverse trig. You know what it is. So let's get going on these examples right down the middle of the page. Inverse sine of 1/2. All right, let's try this one. Inverse sine of 1/2. So I have this drawing here, and that is approximately 1/2, or it should have been. And so there's 1/2, roughly. And you know that that generates a 30, 60, 90 triangle, and the sine, the opposite side there, would be 1/2 if the angle on the inside was 30 degrees. Inverse trig is always going to give you an angle. All right? So let's try number 2. Inverse sine of -1/2. So they're giving you the ratio again, and we have to get the angle. And so you might think, all right, go all the way around to 330 degrees, but it is not 330 degrees. All right? Believe it or not, it is not. It is equal to -30 degrees. And yes, those are coterminal angles. In many ways, they are the same. But for inverse sine, for reasons we'll talk about in just a moment, it's going to be -30 degrees. We'll get to that in a second. Number 3, you can have inverse sine of, say, 0. Not 0 degrees, remember, this is still, it's a ratio of the sides of the triangle. In the case of sine, it's opposite over hypotenuse. So the opposite side must be 0, and the hypotenuse can be anything. Usually it's 1. In a unit circle, it's 1. And so that's only when you have a 0-degree angle. All right, so once again, all our answers here in red are angles. So let's work over on the left-hand side here. We got sine x, all right? And here's your typical sine wave, and you can notice we only highlighted certain parts of it. In part 2 of our video, we'll talk more about why only that part is highlighted. But we're going to restrict our inputs, our domain for sine. When we go to inverse sine, we'll restrict our answers to -pi/2 to pi/2. So our range for inverse sine is going to be restricted in radians, -pi/2 to pi/2, or in degrees, -90 to 90 degrees. All right? In cosine world, you notice that the highlighted part here was for sine, and here it is for cosine. For cosine, inverse cosine, the range is from 0 to pi, which is the same in degrees as 0 to 180. So we're going to restrict all our answers there. So let's do an example here. I guess this is number 1. Inverse cos of negative 1/2. All right, so I look at negative 1/2. That's about there. Remember, we're on the x-axis for cos. And there's, in the unit circle, there's a couple answers. That's one, and that's another. For reasons we'll talk about again in video 2, we're just going to take the one that's in the highlighted area. All right, and that's 120 degrees. We're not going to take this one down here, which I believe is 240. We're only going to be looking at 120. There's only one answer to an inverse cos, or an inverse sine, or an inverse tangent and question. Example number 2, arc cos. All right, again, arc cos is the same as inverse cos. Those are the exact same. And now we're taking it of 1. Remember, that's not 1 degree. That's a ratio once more. And the arc cos, the angle that gets you a cos of 1 is 0 degrees. All right, so let's get into inverse tan. Inverse tan goes from negative pi over 2 to pi over 2, or negative 90 to 90. That should be familiar. It's just like sine. We haven't looked a lot at the tangent waves, but here's a picture of them, and we're only going to be in that little area when we're talking about inverse tan. All right. So to review sort of how it works, you got your functions. They all look like that. You can also write them with the word arc out in front of them. The domains, you might recognize these domains as similar to the domains of the sine function, or the range of sine function was negative 1 to 1. The range of the cosine was negative 1 to 1. We didn't talk much about the tangent range, but the tangent range was negative infinity to infinity. Now that we're in inverse mode, inverse sine, inverse cos, inverse tangent, the domain and ranges have switched. One thing to note about the ranges is not quite what the domain of sine was. The domain of sine was negative infinity to infinity, but we restricted it to negative 90 to 90. We've done the same thing with tangent. And remember, with cosine, we go from 0 to 180. All right. So back to another boating example. You're tying onto a dock here, and you're interested in angle theta. And you have a rope of some unknown length s. And in green there, that's actually a 5 there. It looks like an S. But the height of the dock over the water is 5 feet. All right. See it a little better in this picture over here. So we were asked to write theta as a function of s. So this is just triangle trig, SOHCAHTOA. Sine of theta is equal to the, it's always going to be equal to the opposite over the hypotenuse. And the opposite is 5 feet, and the hypotenuse is s. All right, so sine theta is equal to 5 over s. When we want to get just theta and remove it from sine, there is a way to do that now. We're going to do inverse sine. We're going to take inverse sine of the left side, and we're going to take inverse sine of the right. And we do that, inverse sine and regular sine cancel each other out, as they should, and you got theta equals inverse sine of 5 over whatever the s rope is, that length. All right. And number 2, now we're actually putting a number onto it. The rope, if it's 52 feet long, and theta is, and you can do this on your calc, do it just a moment, inverse sine of 5 over 52. All right, you're going to get back an angle. And hopefully you realize from those numbers that the angle is going to be small because your opposite side compared to your hypotenuse is going to be real small. So we'll go to our calc. Inverse sine, that's the blue button above sine, 5 over 52. And I made sure I was in degree mode, and out comes 5.5 degrees. So our angle's 5.5 degrees, pretty small. Working in a whole other realm. There's this idea of angle of repose, which for any kind of substance like sand or salt, if you try to put them in a mound, right? Try to put them in like a cone-shaped mound and just pile up sand and salt, there'll be a certain angle there that substance naturally has, and it's different for different substances. So you would know a lot better if you went to the Return of the Jedi, watched the whole thing, and paid attention to the Great Pit of Carkoon, which is on the planet of Tatooine, not far from Jabba the Hutt's place, where he puts all his prisoners in and kills them, because the Sarlacc is down in the middle there. But if you weren't aware of that, believe it or not, they stole this idea from ant lions and unrelated worm lions. And what these little insects do is they are very aware of the angle of repose for sand. All right, and they fling loose sand into sort of a conical shape, and then when another insect, usually an ant, blunders their way into the conical shape, they start to slip because that angle is at the maximum angle it can be, and as they slip, they fall down, and the sand fall down, and eventually they end up down the bottom. This has to do with snow, of course, has an angle of repose. It's 38 degrees in general. I know there's different types of snow, but depending on the snow's composition and other factors, it can be different than 38 degrees, but overall, snow rests at 38. So, moral of the story, keep away from the Sarlacc, for sure. That's Mr. Dean. We're Mr. Dean. We're out of here.